Hi, Algebra 2. This is Unit 4, Lesson 12, and today we're going to talk about the number e and natural logarithms. So the number e is actually an irrational number, just like pi is. It's called e for its inventor, Leonard Euler, and it plays a crucial role in calculus, but we're going to introduce it right here to you. So e is an irrational number. I'm just writing down what e is. Irrational number with an approximate value of 2.71828, and then it keeps on going on and on and on. E often occurs as a base of exponential and logarithmic functions that describe real-world scenarios. So base e for an exponential function. Exponential functions with base e are called natural base exponential functions. An example would be f of x equals e to the x. Base e logarithmic functions. Logarithmic functions with base e are called natural logarithms. An example is f of x equals log base e of x. But oftentimes we write that as f of x equals ln of x. So that ln is the natural logarithm, and it's actually a button on your calculator. Okay, it's right below that log button. So basically, the natural log of x is the same thing as the log base e of x. All right, example 1. Which of the following graphs below shows y equals e to the x? Explain your choice. So look at them and try to figure out which ones are exponential. Okay, 2 of them are exponential. And hopefully you picked that it would be either 2 or 3. 1 is just a parabola, so that would be y equals x squared, although it's been shifted up. Now remember that e is approximately 2.17. Okay, so which of these exponential graphs, choice 2 or choice 3, is greater than 1? So I want to know which is greater than 1. Because the one that's greater than 1, remember, y equals b to the x. If b is greater than 1, then the graph is increasing. So hopefully you pick choice 2. It's an exponential, and also since e is a positive number greater than 1, then that graph should be increasing. All right, natural logarithms follow the 3 basic logarithm laws that all logarithms follow. So the product law, exponent, when I'm multiplying, they have the same base, I add the exponents. Logarithm, though, log base b of x times y is log base b of x plus log base b of y. We saw this. The natural logarithms follow the same law. Quotient rule, if I'm dividing and I have the same bases, I subtract them. In log world, log base b of x divided by y, then I take them and I separate them and I subtract them. Power rules, b to the x to the y equals bxy. In the log world, log base b of x to the y, that y, that exponent comes out in front, y times log base b of x. So that was just a review of logarithms. Something important to keep in mind with the natural logarithms, though, is that the natural log of e equals 1. They cancel each other out. They are inverses. So if you have the natural log of e, it will cancel out. Inverses, and they cancel. So keep that in mind when we start to solve these. All right, flip over to the next page. We're going to write each of these equations in logarithmic form. So e to the x is actually log base e of 24 equals x. Okay, right? My exponent is what my answer is. This is my base, log base e of 24 equals x. And since I have the log of e, that's actually just the natural log of 24, oops, that's a 4, equals x. E to the 9 equals x. Again, log base e of x equals 9. My exponent is my answer. And this right here is the natural log. So I'm just going to do natural log of x equals 9. I want to go back the other way and I want to write it in exponential form. So a natural log of x equals 58. Let me write it as a log. Log base e of x equals 58. And now I think it'll be a little bit easier for you guys to write as an exponent. The 58 is the exponent, so e to the 58 equals x. Okay, so I'm going to take the natural log, I'm going to write it as a log, and then I'm going to write it as an exponent. I'm not going. If you can go from one to the other without doing that middle step, then that's fine. The natural log of 6, so that's log base e of 6 equals x. And now I'll write it as an exponent. E to the x equals 6. All right, let's practice condensing these. So natural log of 3 plus natural log of 16. That's the natural log of 3 times 16, which is the natural log of 48. All right. Natural log of 63 minus 2 times natural log of 3. So remember, when I have subtraction, I'm going to wind up dividing them. So natural log of 63 divided by 3 squared. Because this 2 goes back up into as an exponent, and that's the natural log of 63 divided by 9, which is really just the natural log of 7. So that simplifies quite a lot. And then if I wanted to expand these, I could just do natural log of 5 plus the natural log of x. And if I wanted to expand b, I would take this. Everything's being squared. So this is actually the natural log of a to the 6 over b squared. And then I want to expand it. So the 6 is going to come out in front. 6 times the natural log of a. When I'm dividing, I'm going to make that subtraction. And then that 2 on the b, that exponent of 2 comes out in front. 2 times the natural log of b. All right. Let's try solving some. So I'm going to solve each equation below. Just like before, if I have the natural log and the natural log on the left and the right, then all I have to do is to take these and set them equal to each other. So 4x minus 27 equals 15 minus 2x. As long as the logs have the same base, and you just have a log on the left and a log on the right, you can sort of drop those logs out and then just solve. So I'm going to add 2x. I'm going to add 27 is 42 and divide by 6. Okay, let's simplify this. So this 2, I'm going to write it as natural log of k squared. And then I have natural log of 2k plus 15. So as long as I have the same log on the left and the right with the same base, then I can take what's left and set it equal to each other and solve. Now hopefully at this point you recognize that this is a quadratic. Everything needs to come to one side. So I'll bring that 2k over and I'll bring that 15 over, and then I'm going to factor it. So I'm saying to myself, what numbers multiply to 15 and add up to negative 2? So that's a negative 5 and a positive 3. And then I set each of these equal to 0, which just results in changing the signs. Now remember, I got to test these out to see if there is extraneous roots, extraneous solutions. I can't have the log or natural log of a negative number. So I'm going to cross out that negative 3. The negative 3 will not work. All right, let's look at C. So I have this 2 is going to come up and become the exponent for the m plus 4. And I do have the natural log on the left and the natural log on the right. So basically I just have m plus 4 squared equals 4. Now m plus 4 squared really means m plus 4 times m plus 4. That's m squared plus 8m plus 16. So be careful with that. Again, I need to bring everything over to one side. M squared plus 8m plus 12 equals 0. And then I'll factor it. Factors of 12 that add up to 8. So I need numbers that multiply to 12 and add up to 8. That will be 6 and 2. But when I set them each equal to 0, they wind up being negative 6 and negative 2. Again, you got to be careful when you're negative 6. Negative 6 plus 4 is negative 2, so that will not work. Negative 2 plus 4, that's a positive, so that's okay. All right. And then I have the natural log of 8x equals 2. So I'm going to write that as log base e of 8x equals 2, just because I think if I skip this step, you guys might be a little confused. So e squared equals 8x. Okay, and you can just do e squared in your calculator. So e squared is, let me get a calculator here up. So e squared, where'd my calculator go? So you can see that e is right above that division sign. So second e, and then squared. So e squared is 7.38905, and that equals 8x, so you do have to divide by 8. I'm going to do that all right here since I'm here. So I get 0.9236. It didn't say how to round those off, so I'll just write a couple of decimals there. All right, so that's the E button on my calculator. So E squared again was 7.389056 equals 8x. Divide by 8, and x is 0.9236. Okay, so I'm just practicing these natural logs the same way I solved logarithmic equations. I'm doing natural logs. All right, e to the x equals 57. So this is really the natural log. I'm going to take the natural log of, remember when I had a problem, I'd take the log of both sides? Well, this is e, so I'm going to do the natural log of both sides. The natural log of e to the x equals the natural log of 57. I'm going to take that x and bring it out in front. And then the natural log of e is just equal to 1. This right here, those are inverses. They cancel out. So that's the whole reason why I want to do this. So x is just the natural log of 57. And I can do that right in my calculator. So my calculator, the natural log is right below the log button. Natural log of 57. And that is 4.04305. As long as we're here, natural log of e. So I'm going to do natural log, and then I'm going to put in my e just to show you that it does in fact equal 1. So instead of taking the log of both sides, when you have an e, you're going to take the natural log of both sides, and that will cancel out the e. All right. So what did we say that was? 4.0431. All right. And similar on f, except remember I have to isolate that exponential, so I'm going to subtract 3. And I'm going to have 2e to the c minus 9 equals 84. I still need to divide by 2. So I have e to the c minus 9 equals, what is that? 84 divided by 2 is 42. Now I'm going to take the natural log of both sides, because that will get rid of my e. The c minus 9 is going to come down in front. And I got natural log of e, natural log of 42. Natural log of e just equals 1. So to solve for c, I'm going to add 9. I'm going to do the natural log of 42, okay, which is 3.7136. And to solve for c, I'm going to add 9. So I really get 12.7136. All right, and then we have some llamas. So a population of llamas on a tropical island can be modeled by this equation right here. P equals 500 e to the 0.035 t, where t represents the number of years since the llamas were first introduced to the island. How many llamas were initially introduced at t equals 0? So I'm just going to take that equation and plug in 0 for t. Well, 0.035 times 0 is just 0, okay? And e to the 0 power, anything to the 0 power, is just 1. So this is 500. Okay, I don't know if I lost you guys. Maybe I should write that in between step. It's 500 times e to the 1. I'm sorry, e to the 0, and e to the 0 just equals 1. Algebraically, determine the number of years for the population to reach 600. Round your answer to the nearest tenth of a year. So I know my p. I want to know when it equals 600. So I'm still just writing this equation, 500 times e to the 0.035t. All right, so I'm going to get e by itself by dividing by 500. 600 divided by 500 is 1.2. And now whenever I have an e, I'm going to take the natural log of both sides instead of the log. The reason I do that is because the natural log of e cancels out. Now that 0.0352 comes out in front. It's an exponent, 0.035t times the natural log of e. And the natural log of e is 1. So that's gone. And I have 0.035t, so I have to divide by 0.035. And I'm going to do natural log of 1.2 divided by 0.035. So in my calculator, natural log of 1.2 divided by 0.035. So I get that t by itself, 5.209, and I think it says I want to do it to the nearest tenth of a year. So t is 5.2. Okay, so my variable, my t, was an exponent. To get it out of the exponent mode, I do the log, or in this case I do natural log because I'm trying to get rid of that e. And just to see what a multiple choice kind of question might look like, which of the following is equivalent to the natural log of e to the third divided by e squared? So this division, I'm just going to expand them and write them as subtraction. See if that helps a little bit. And then remember, any exponents come out in front. And the natural log of e is just equal to 1. Okay, so you can see